Good evening. I want to welcome everyone, premium members and public, members who've been following the website. I'm doing a little special, let's say an early Christmas slash Hanukkah present, basically showing what you get as a premium member when I do these videos. And for tonight, we have a couple of interesting, let's just say, model data that has come out that shouldn't be a surprise if you've been following what I've been saying for the past several weeks. So first I want to show the QBO index. This is at 30 millibars right here. And notice for 2011, we went from a strongly positive QBO at 30 millibars. This is in the stratosphere now. And we've seen a rapid drop down to minus 9.09 as of November. Okay, so we're now in December. So if we continue this trend, we can pretty much assume that the QBO is below minus 10 at this point. And that's very important because minus 10 is the threshold in which then we start to see influences in the stratosphere and influences in the higher levels of the troposphere, in other words, the 500 millibar pattern. Now, one very important thing I want to make very clear about the QBO. What this is not temperature. This is the magnitude and orientation of the winds at the stratospheric level at the tropics. Why is that important? When you have an easterly wind in the tropics at the stratosphere, it becomes easier to transport that warm air over the equator and over the tropics, even in the stratosphere, to the higher latitudes. The reason why is very complicated. I'll try to explain it in some future long-range forecast discussions, but it'll probably take about an hour or so to explain it on this video, which we really don't have time for that. But when we see negative, which means an easterly wind, that is a very big sign that stratospheric warming is on the way, and also that there's going to be a major change in our pattern from a progressive pattern to one that is very, let's just say, blocky. Okay, you start to get these blocks setting up over the northern hemisphere and specifically the higher latitudes between 60 north and 90 north. Now let's go to 50 millibars. And this is important too. Here we are again, 2011. As you can see, up until about October, we were steadily rising. 9.06, 10, 11.46, but then we start to see a major change in November. Why is this changing? Well, you see, the winds in the stratosphere change from the upper levels to the lower levels. So what we're seeing here is a beginning of a change in orientation of the winds from going west to east to now east to west. And that change is going to lead to very rapid and very interesting patterns setting up most likely towards the middle of this month into January, possibly even into February, depending on the intensity of the stratospheric warming events that do develop in the next several weeks. So I wanted to show this because this goes beyond model guidance. This is pure meteorological physics that you can't really counter. All right, it's not like, well, there's a model guidance and the model is going to trend this way or trend that way. This is physics. Physics doesn't change. What happens, one cause, one effect has to have a reaction. And this reaction is going to lead to a fundamental change in the weather pattern that we've been dealing with for the past couple of weeks. I've been warning about this for the past couple of weeks, even though there's been several people running around saying that winter isn't coming, winter is going to be warm, blah, 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 blah. Look, this is physics. This is beyond model guidance. It's beyond the ECMW forecast for 4 weeks out or 3 weeks out or whatever you want to use. This is hard science here. So I wanted to show this to you to get an idea, to basically explain to you why I've been forecasting a pattern change, why I've been going with the step down process. Another feature I want to show you is the convection in the Pacific. Now, why is this important? The reason why this is important is because when you get convection around the dateline, which is right around this area here, you enhance troughs in the Pacific, specifically around the Aleutian Islands. And when you enhance troughs around the Aleutian Islands, well, you end up with a negative EPO pattern. You combine this with what's going on in the stratosphere, and you start setting up a rather persistent and rather dynamic weather pattern. The reason why? This is the subtropical jet stream. Now, last year, this subtropical jet stream was pretty much dead. We had a moderate to, in some cases, a strong La Nina, and that suppressed convection throughout the tropical Pacific. But this time we have a weak east-based La Nina. Notice there's barely any convection around the eastern quadrants of the El Nino Southern Oscillation areas. Okay, so this is clearly a textbook view of an east-based La Nina. And what this means is that we're going to set up a split pattern. Now, in my long-range forecast discussion, I put the potential for an upper-level low to develop around the southwest that would lead to basically a slight ridge over the southeast. Okay? Now, this ridge over the southeast would not be able to build. Why? Because we have convection around the dateline, which enhances the negative EPO pattern, produces a ridge, look at that, which leads to a trough in the east. Now, because we have a split pattern, what we end up with are rather dynamic and interesting storms that are not like the storms we've seen in the past couple of years, where we see these disturbances dive south, phase, and bomb out off the east coast. Now, they'll still happen, but what we're going to be dealing with also is what we call isentropic lifting type storms. Those are the type of storms where warm air is trying to invade to the north, but cold air is dominating the northeast and the northern mid-Atlantic, which leads to storms that feature snow, sleet, freezing rain, rain back over to snow, that whole mess. These type of storms are not the typical type of storms that feature very powerful low pressure systems, but more like a stationary front with one strong upper level low shooting off disturbances and moving towards the northern mid-Atlantic. When you look at the winter forecast I have out, even at the public section, you will be able to see that I have a rather impressive thermal gradient where we have very cold air here, warm air here, and a very strong thermal gradient over the mid-Atlantic, back through the Tennessee River Valley and towards the southern plains. Now remember when I said that. Now let's move to the European model guidance. Here we have the European model guidance. I'm going to move back to, let's say, 120 hours. Okay, now at 120 hours, we see a couple of interesting features. We see an upper level low over the southwest. We see a ridge trying to build, and we see a disturbance over portions of the Northwest Territories in Canada. We also see a ridge trying to build around the Gulf of Alaska and a trough around the Aleutians. This is I guess you could call it almost like a hybrid negative EPO pattern. Now, this clearly would not support a snowstorm that we're used to seeing the past few years, mostly because look at the Atlantic. It's a very progressive pattern with a positive NAO pattern. This would lead to a very fast-moving storm if a storm should develop. Of course, in this case, on Tuesday morning, we have high pressure, and temperatures are basically near normal or slightly below normal. Nothing too significant. Now, moving forward in time through next week, you could see some interesting changes take place. By 168 hours by Thursday morning, we have an upper level low around the Aleutian Islands. Look at this enhancement here with this trough. Now, I don't buy this. This is probably an error. But the point here is that we have a trough around the Aleutians, a ridge building into Western Canada. And look at this. We're starting to see our polar vortex drop south. Textbook influence of a QBO that is changing, ladies and gentlemen. And we also have some rather strong disturbances in our southern jet stream, our subtropical jet. Now let's be clear about this. This pattern is split. This is not the same pattern we've seen the past few years where we basically have a polar jet stream / Pacific jet stream dominating the entire weather pattern. This one is clearly a split pattern. And we could see that with our temperatures, where very cold temperatures, Arctic air is building over Canada, where, by the way, snowfall amounts are well above normal for this time of year. And very warm air is building over the southeast, and you can see our thermal gradient already starting to develop. Moving forward in time, by next Friday, now look at the fundamental changes we're seeing in this weather pattern. We're clearly split, but look where we're having our interaction setting up. This is an impressive thermal gradient here. We're going from plus 10 degrees Celsius to minus 10 degrees Celsius. Almost a 20-degree thermal gradient over the eastern United States. When you get this type of thermal gradient setting up, you end up with one thing and one thing only: a potential isotropic lifting event. In other words, cold front stalls out, and you get precipitation developing light at first throughout the entire northern Atlantic back through the southern plains. Another key point to just point out here, we have convergence and confluence over portions of New England. Here's our low pressure system departing. Look for this high pressure system to build south and east because of this convergence. And we're starting to get a weak negative NAO pattern starting to develop. Our polar vortex is dropping south. Why is all this happening? Because it starts here. When you set up a negative EPO pattern, eventually you end up with a negative NAO pattern and a negative Arctic oscillation pattern. Meanwhile, our subtropical jet stream remains split. Here's our upper level low sitting over the southwest, and it's starting to spit out disturbance after disturbance. As we move forward into Saturday and Sunday. Now, this is going to be a very interesting time period for not only the northern Atlantic, but basically almost all of the East Coast here. Why? Well, again, we have a split in our pattern. And I think we're also going to get a little bit of interaction from the Arctic jet stream as well. So what we have here is a pattern where we have a trough around the Aleutians Ridge in Western Canada and a very deep trough setting up over Eastern Canada. Notice we're getting upper level low sitting up around the Aleutian Islands, and look where our ridge is starting to build into. It's building into Greenland. So we're starting to see all the telltale signs of a negative EPO pattern developing, a negative Arctic oscillation pattern developing, and a negative NAO pattern developing. While this is happening in the polar jet stream, our subtropical jet stream is basically shooting disturbance after disturbance from the southwest right into the mid-Atlantic coast. Again, our surface map, we have a cold front that stalls out just to the south of the northern mid-Atlantic, basically just to the south of New Jersey. Weak areas of low pressure. Here's our more powerful area of low pressure. Again, Arctic high pressure is building into the plains, building into the Great Lakes, and ridging into the northern mid-Atlantic. Meanwhile, look at our winds. Well, what did I say a couple weeks ago? That the ridge axis that was sitting over the Gulf of Mexico is going to shift to the east, and it's going to be setting up around the Bahamas. Well, look at our wind circulation here. Our wind circulation centered around the Bahamas. We get this south to southwesterly wind coming out of the Gulf of Mexico, running up against a northwesterly wind that is transporting very Arctic cold air. We have these disturbances moving across, and let me zoom in here. Hopefully this works out here. Let me zoom in. Look at this thermal gradient. This is incredibly impressive, okay? Now look, I know it's 240 hours out on the European model guidance, but I want to make this very clear. This pattern would be supported based on the observations we are seeing now in the weather pattern, the falling QBO, the development of convection around the dateline, the development of the negative EPO pattern. All of these are signs in our weather pattern that we're heading in the direction that the European model guidance is showing tonight. And what this would result in would be a very impressive winter storm, not only for the northern mid-Atlantic, but even for portions of the southern mid-Atlantic. Most likely much of Virginia would end up being rain in this scenario, but it'd be a very heavy rain, and you would have a significant threat for ice over portions of the southern mid-Atlantic and even the northern mid-Atlantic. Meanwhile, look at this Arctic air. This is minus 10 degrees Celsius, building south. So again, we're going to have a 10-degree thermal gradient setting up. When you get this type of thermal gradient and you get these disturbances that are moving across the 500 millibars, there's going to be precipitation breaking out. What are the details? No way I could tell at this time. But I am saying this. The idea that winter is not coming or winter is going to be warm is going to fail miserably. And it's not because of a model guidance, it's because of physics. It's because of meteorological law. We're dealing with an east-based La Nina, which influences our convection, which enhances and enforces the negative EPO pattern. We have the stratosphere changing. We have a negative QBO pattern developing in the stratosphere, which is going to lead to stratospheric warming and supports the potential for high latitude blocking. All of these are facts. All of these are observations, and all of these, well, they're going to have a way of showing up, regardless of what the European model guidance, GFS model guidance, or someone's big hat thinks. Okay, these are just facts, and I knew them back in October. I've been saying them ever since. And here we have the step down. Winter is here, and right around December 18th. I might be about 3 days late on my forecast back in mid-October of us starting to see the real action beginning by December 15th. So I'm going to be 3 days late possibly. So that's pretty much the long-range forecast pattern. You could see the evolution of this weather pattern really unfolding. This type of Arctic air mass with this stationary front is setting up some bad news for us. And I would not be surprised if we're dealing with a rather impressive storm as we move forward towards the week of Christmas. So, could we get a white Christmas? Well, if this pattern holds true, and I think it will, I think we'll have a pretty good shot of seeing some snow on the ground by the time Christmas rolls around. That's your long-range forecast discussion. I'm your meteorologist, Stephen DiMartino. Have a wonderful evening. Stay safe out there.